Let's practice with the multiple regression. Multiple regression. So we are going to use the same data set. And the idea is that we want to look at how the supplier integration factors, how supplier integration factors influence operational performance. Okay. Now let's change the dependent variable. Let's look at the data set and pick the one that we can easily interpret for. Let's look at the financial performance. At least one of them is will be on profitability also. So the financial performance, profitability, right? FP6. Look at it. The FP6 is about profitability. So we want to look at how the supplier integration, all of the factors, E6, that is SI1 to SI8, how all of them work together to predict changes in the profitability of the firms.
So supply integration 1 to 8, predicting FP6.
Yes, FP6.
Okay.
So that is what we want to do. So the analysis, we go to analyze as usual. Analyze, and then what do? We go to analyze, then you go to regression. Go to regression. Then you go to linear. Has it open? Okay, when the dialog box opens, this is where we select our variables into them. So our dependent variable is what? As usual, you have to right click to display the variable names. Have you seen that? Okay. So our dependent variable is what?
SI1 to 8.
Dependent variable.
Dependent F6.
Yeah.
FP6.
FP6. So we go and pick FC6 and then place it at the dependent box. You get it? You place it at the dependent box. So you place it at the dependent box. Now we go and select our independent variables. In our independent variables, we have the SI1 to SI8. So you select all of them and place them at where the independent variables are. Place them there. Then you go to statistics. Statistics. You click on that. Then you click on model fit is already selected.
Yes.
Estimates is also selected. So you can take the descriptives, part and partial correlation, correlative diagnostics. Okay. Then you come to Darwin waxing at the residual. Have you seen that? So go to Darwin waxing. And what does Darwin waxing test?
Then the multiple.
No. Autocorrelation. Whether there is serial or autocorrelation between the factors for the variable. Okay. Then go to continue. Then click on plots. On plots, you see what they call zip rate, right?
Yeah, zip rate.
Zip rate. Move it to Y. Then there's what we call zero zip.
That's the first one.
The first one is zip rate. The second one is what? Zero zip. You place it at where? The X. Come to the standardized residual plots. Standardized residual plot. and click on histogram and normal probability plots. And then you continue.
So the zipper and what are the others?
They are technical terms. Take as you have been told. Okay. Then the next one is that you go to distances. If you go to distances, click on what? I can't pronounce it. What is the name?
Distances.
Like you go to save, you click on save.
Okay. What's that asking the question?
Click on save,
Okay.
and this box will come. You take what? You take Mahalanobis, right? And then you also take what? Cooks. These are the two things that you take at the distances. Then click on continue.
So the answer that I should not take that.
Don't go there. The two that yes, so what are they? Mahalanobis and what? Cooks. Then click on continue. Then go to options. Then at missing value, click exclude cases pairwise. Okay? Exclude cases pairwise. And then click on continue. But at the method section, make sure that enter is selected, okay? At the method section, make sure enter is selected. Is it selected?
Okay, yeah.
So just click on OK, that's all. Click on OK. And your results will come, boom. So the descriptive statistics are there, which correlations are there, which you are not much concerned with. I said that when you run it, you have a host of results, right? And which tables do you have to consider first?
The model summary.
Okay, so you copy the model summary and put it here. Model summary. After the model summary, which other table you have to look out for? Critical table you have to look out for.
Look at the annual.
You copy it and paste it there.
We have their names in this window, the left side.
Yes.
Right.
So me to run away, go and search it.
Instead of scrolling down, just
Okay. Then you go to coefficients. I told you coefficients, look at the contributions, are not it. So we copy the coefficients and then place them. These are the three critical results that we have to evaluate under the multiple regression. Okay, so quickly we just go and then try to interpret the results as we have found them. Let me make a landscape so that we can edit this table. So, first table that we have to look out for is what we call the model summary. And the model summary, what did we say we have to look out for first?
We should look at the joint correlation R.
So, what is the joint correlation there?
R is 0.599.
Now, listen to this statement carefully. You see, R square is always positive, or I just said R square is always positive.
R square is always positive.
Yes, but you know that correlation, you can get positive or what? Negative.
Negative, yes.
And then square root of negative is what?
That's positive.
Positive. So you must always be very careful with the way you interpret the results here. Before you will say that the predictors are improving the dependent variable, come and check the behavior of the joint correlation. If it is negative, then it is not improving it. It is rather what? Reducing it by that particular margin or percentage. But if it is positive, then you can see that it is increasing it by that particular what? Margin.
Okay.
So I said that this joint correlation because it's the correlation between all these predictors. All this on one hand, okay? As against what?
The dependent
Very good. As against the dependent variable. That is what I mean by that. So when you sum all these predictors, including the constant contribution, you add them on one hand, and then you take them against the dependent variable. Then it is explained by the joint correlation, which is the word R. And it can be negative or positive. And you can also use the same criteria to explain it. Talking about the threshold.
Okay.
So if you look at this, it's about 0.5.
Yes.
So we say that it's large what? Positive joint correlation between the predictors and the dependent variable, which is the stability. Okay. So that is that. But before we touch on that, we should have looked at the Darwin-Watson. I said the Darwin-Watson test for what assumption?
Autocorrelation.
Autocorrelation.
It will be 1.5 to 2.5.
Okay, so what did we get here?
1.973.
So
within the range.
it is within the range, right? So we conclude that there is no autocorrelation or serial correlation between the predictors and the dependent variable.
So I mean that assumption is satisfied.
Yeah, that assumption is satisfied. So we can go on to now look at the actual impact of the changes in the dependent variable. So the changes in the independent variable to the changes in the dependent variable. Okay. So the coefficient of determination is represented by what? The R squared. Now with this R squared that we have here, you just have to multiply it by what? 100. You multiply it by 100.
35.9%.
So that's going to be 35.9%, which means that changes in the predictors, including the constant, cause how many change in the dependent variable? 35.9% change in the dependent variable. Okay, so that is that. But I have to give you some information to help you to classify the R squared. To classify the R squared. Like the correlation to, we also have classification for the R squared.
Okay.
So you can see that it is weak, it is moderate, or it is substantial.
Okay.
Good. So I'm going to give you material for that.
Just stick with the 16.
Okay.
All kind of response.
So
what is spiral R squared? R squared as follows.
okay.
So 0.67 substantial.
So when you get above 0.67, you see that the change is what? A substantial change. When you get above 0.33 but not up to 0.67, you see that it is what?
Moderate.
Moderate. And when you get from 0.19 up to 0.32, you see that it is what? Weak change. That's all.
So our own is moderate.
We got 0.359.
59.
So 359 will fall on average.
Only moderate, yeah.
Yes, under moderate. So that change is what? Moderate. You get it? So we can say that the predictors, including constants, we have high degree of joint planning, blah blah, all those things, they cause moderate change in what? Profitability. That's all.
Right. Why, with a very good source. Fine.
Okay. So that is how we are able to classify the R squared.
They said they gave me how to classify, how to interpret like a scale.
So today too, I'm giving you how to interpret the R square. So that is that. Then, having substantiated that, it causes moderate change, and it is positive, right?
Yeah, it's positive.
You have to come and check whether that change, the R square, is significant or not significant. So you go to a table called ANOVA. That is what I told you about.
That's why you check significance. So there is significance.
So the sig value is here. What do we get as the sig value?
0.002.
0.05. Yeah, you got 0.00. Sorry for the interruption. So if you look at the R square, so if you look at the P value measured by the sig, is significant. So we conclude that that 35.9 change is what? Significant, not because of what? Chance, but it's a true reflection of changes in the independent variables, predicting what? Changes in the independent variable. That's all.
So supply integrating factors. Supply integrating factors predict them profitability.
So what factors are predicting? These are the factors.
High degree of joint planning. Then rapid response modeling processes.
Okay. We synchronize business activities with those of key suppliers. We work with suppliers to improve their quality in the long run. We constantly explore new working relationships with suppliers. We pursue. That's why we share sensitive business information frequently with supply chain partners. We pursue supply interrelationship and involvement that go beyond operational transactions. We keep key suppliers informed about events or changes that may affect them. There's a real-time checking on total stock with key supply chain integration partners. So these are the predictors. They are actually factors causing that change. I told you that the sig value also signals also shows that at least one of the predictors is making significant contribution.
Yeah, you said.
So we cannot say that the 35% change is caused by all these. So that is how we have to come and look at for their contribution at the third stage.
Coefficients.
To look at their coefficients.
Coefficients.
Yeah. To check which of them are contributing to that 35%, 35.9% we are quoting.
But it's a process.
Yes. So we go to the second one, the second table called the coefficient. I told you that we have two types of results in the coefficient table. We have standardized and what? Unstandardized. I said we look at the standardized when we want to look at compare which of them is making significant contribution and higher contribution, okay, or the least. So with the standardized, what we do is that we just compare them. Just compare the predictors. So with the standardized beta coefficient, that one you ignore whether it is positive or negative. You take the absolute.
Okay.
The one that is higher or highest and is significant is the one that we talk about. Then you can see that, oh, among the predictors, this is the one that is actually contributing much to the 35.9% change that we got there. Okay. So we start to evaluate the results. We have standardized. Have you seen the standardized coefficient?
Yeah.
We have unstandardized and what? And then standardized coefficients. So we are looking at this column. Standardized as against the P value. Okay. For each of the factors that you consider, you have to also consider SP value. Okay, SP value. So let's look at the P value. And the P value is represented by what? The sig. Let's finish this, then I'll talk about the multicollinearity. You see. Okay. So to make significant contribution, as usual, the P value should be what?
Significant.
Should be less than or equal to what?
0.05.
Okay.
So 1, 2.
So you say that we synchronize this one.
That's a significant contribution.
Is it significant?
Yes, that's a significant contribution.
But that's the contribution, right?
0.215.
We constantly, it is part of this one. This is not significant, right?
Yeah,
this is not significant. So
yes.
we make it red.
Yes.
Not significant.
That's a significant contribution. This is significant.
Significant, we make them green.
Okay.
Make them green. Not significant, we make them what? Red.
Red. So that one is significant.
But look at it, it's negative.
It's negative. But
Yeah,
it's not take the absolute value.
Yes. Good.
0.85.
Not significant. This is red. This is what? Significant. Green.
0.7. We are going up. There's one.
It is also
significant.
significant.
Yes.
But the rest are not significant, right?
The rest are not.
So make them red.
Yes.
So
So
we have 4. So look at this one. Which of them has the highest number?
The second one.
The second one, 0.4.
4.
Negative,
4,
yeah.
8,
So,
negative.
but it is negative. So is it improving the 35% or is reducing it? It is reducing it. So if it is significant, it is reducing it. What advice do you give to management? Instead of improving the profitability, it is reducing it by this margin.
So let me say we pursue supplier, pursue supplier interrelationship and then involvement that go beyond operational transactions. And this one is reducing the profitability significantly.
Yeah. So what do you tell them?
That thing we may have to stop.
They have to stop. They have to stop. Because instead of it to improve your profit, it is rather reducing it by this money. Which is a waste of resources. Unless it has bearing on other things apart from our profit.
Okay.
Maybe it can have significant positive impact on other aspects of the business, but not on what profit. If we can substitute that and they can do it. Other than that, we tell them to what? Stop doing it. Because it's just waste of resources. Okay. It is followed by what?
Let me see the other one. 2.87, 2.97.
It is followed by what?
And
This one.
yeah, by sports, that one is positive.
Yeah. So what do you tell management to do?
That one they can improve upon it.
They should keep on doing it.
Doing it.
Because this contribution is
Work with suppliers to improve their quality.
in the long run. So you tell the supply chain partners, the poultry farmers, to work with their suppliers and always make quality the main goal for the long run. Because when they do it, it improves their profits. It is positive. Have you seen how this inform decisions? So data analysis is, yeah, when you do data analysis with statistics and you have checked validity and everything, so what you have done is that you don't talk anyhow as a researcher.
Yeah.
You talk with what? Facts.
Facts.
So you go there and you tell them that those of you who are doing integration, you have to make sure that you make the quality the main focus with your suppliers and in the long run, so that you can improve your profit. And when they do it, definitely their profit will increase by some margin.
That's a good consultant.
Yes, that's how it's supposed to be. Okay. Then this is followed by the 2.87. We share sensitive business information frequently with supply chain partners. So we are partners with you in a business. So information that can cause change, that can help us to take advantage of the business environment, and we have to share it. If we can't share sensitive information for us to be more proactive and become more competitive, then there's no need for us to do things together. Is that not it?
Exactly.
Yeah. So if they do it too, the data also shows that it will also improve their profit margins. And then we come to the last one.
The last one.
Which is at the top there.
The top there.
We synchronize business activities with those of keyword suppliers. Not all activities that are business activities. So business activities that they are serving their customers and all those things, they are doing certain things collectively to be able to make some earnings by serving their customers. That's our business activity. So when they do it together, they also it improves their profit. They also get their share from it. So other than that, all the other ones, those that are not significant, you tell them not to worry themselves.
They don't bring any contribution.
Yeah, it's waste of resource, waste of management time, so they shouldn't. That's all. So with this, you can estimate your regression function. And in estimating the regression function, you use the unstandardized beta.
Okay. Okay.
You use the unstandardized beta. So when you are estimating the regression function, look at the beta and also look at the sig value. Okay. If it is significant, you include it in the function.
Okay.
If it is not significant, you ignore it.
Okay. Okay.
So let's create a hypothetical case here and just try to write the regression function. So at the end of it all, remember our contribution, you have to look at it from the perspective of constant. Remember regression function.
Yeah.
Are you mathematics teacher?
Oh no.
Y is equal to what? Constant plus beta by R, times X, right? Remember that thing?
I remember I forgot.
Plus and then error term. Is that not it?
Yes.
Good. So the same thing. What is our Y here? Which is the dependent variable?
Your profitability
So profitability
is equal to constant.
So it's equal to constant. What is the constant? What is the beta for constant?
For this particular.
Yeah. Have you seen constant here?
The constant. I can the figure hiding somewhere.
No. This one is not beginning to see.
3 points.
Yeah.
955.
So that is the constant. And you must check. You only include the constant in it when it is significant. If it is not significant, don't bring it.
Okay.
So look at the
significant.
The significant. That's what you are bringing. So it's not automatic that always constant should be there.
Okay.
If its contribution is not significant, don't bother yourself to bring it. But if its contribution is what? Significant, then you bring it. So the constant is 0. What?
No, it's 3 points.
Sorry, 3
points. 955.
955. Okay, so it's significant.
Yes.
So plus into brackets.
Points.
So which one? We synchronize.
Yes.
We copy this one. Okay. If it has a code name, we can put the code name there. Times what? 0.169.
So mean that the code name, we can go there to bring the code name.
Yeah, we can go there and bring the code.
Okay.
But until then, let's use this one.
Yes, sir.
So this one, the next one becomes what?
Let's see.
Times what?
And
negative
negative
0.461 plus to bracket. We share so have you seen how we do the regression function?
Supplier.
I mean, the learning has become very easy for me because you are advancing it. It's not like you don't have any knowledge at all.
Yeah.
It's already 0.146.
146.
And then plus the last one is what?
We
work with suppliers to improve the quality in the long run, right?
Yes.
So times 0.218. So we are done, right? Good. Okay, now let's go into the data file. Yeah, that's all. So let's go to the data file and replace them. So you said that we synchronize business. That one becomes what? SI1. Okay. We pursue supplier interrelationship and involvement. That is what? Supplier integration. Is it 2? No.
I think we use all the.
That is 3.
Okay. The way they are.
That is 3. It means the same thing, right?
Yeah.
So we share sensitive information. Where is it? We share sensitive information. There's 5.
Yeah.
Supply chain integration 5. We share sensitive.
No, the other one.
Yes.
Share sensitive information. We understand. So
So we
let's
share
just
supply chain integration what? 5.
5 by
And then we work
with suppliers to improve.
that is 6. Supply chain integration.
Yeah, that's 6.
Yes. So
Simplify the equation.
yeah. So these are the things that they do to improve their profitability. That's all. So that is the whole about your regression.
Why? So now we before the research we assume that almost all these will predict from profitability.
Yes.
But I don't know the study. The results indicate that about 4
Good.
items.
Yes. The estimated regression function, right? It's given by this.
So we look at the function.
So this is the estimated regression function simplified, and this is multiple